I hear from students every day who are feeling absolutely stressed about the Algebra I Regents, so I'm here to hopefully make you feel calm, whether it's with the sound of the iPad, the soothing sounds of my voice, or by helping you realize that you know more about math than you think. We're going to do this one problem at a time. I'm going to talk calmly, I'm going to think slowly, and we're going to go over it. Okay, so question number 1. I'm going to talk at a 6th grade level because that's what I teach. So if you don't know past 6th grade math, let's figure it out together. This says a parabola. Ooh, let me change that pen. A parabola is graphed on the set of axes below. Let's talk about those two words first. So a parabola is the shape of a graph. Specifically, it's one that looks like a U or one that looks like a frowny face. It's like a happy face or a frowny face. These are called parabolas. So if you're playing along, I would write that down. Even though it says it there, I like to write it down just because parabolas. So on the graph, we have a parabola, and it says on the set of axes. So when they say axes, they're just talking about two things. They're talking about two number lines that we draw together, and we call them the x-axis and the y-axis. Together, they are axes. Like an axe and an axes. It's the plural of axis. So if you've never seen that word, that's what it means. So it's graphed on this set of axes below. This is the x-axis. This is the y-axis. Okay, shall we keep reading? Yes, of course. Good. It's my video, so I guess I'm in control. What are the... Hold on, I want to switch to a little highlighter situation here. What are the equation of the... So we need an equation of something. An equation of what? Okay. What are the equation of the axis of symmetry? Okay. And the coordinates of the vertex. Okay. All right. A lot more words here. Let's look at them. Okay. So an equation. So often with like an equation has an equal sign, and lines and parabolas and stuff like this on a graph, they have equations that match them. So this parabola has an equation, but it's not asking for the parabola's equation. It doesn't say what are the equation of the parabola. It says what are the equation of the axis of symmetry. So let's look at that. What does that mean? This axis of symmetry, if you know the word symmetry from the word symmetrical, it's something that like cuts one of these parabolas right in half. So it, depending on what the parabola looks like, it just slices it right in half. That's terrible. Look at, okay. We're gonna redo that. Precision. Okay. That one's gross too, but we're gonna leave it. You know, happy accidents. That's what Bob Ross would say. Okay, so in this parabola, we're gonna say that the axis of symmetry would be drawn right here. And the reason it's called the axis of symmetry, if you haven't guessed yet, is because it cuts right through this parabola and cuts it into two symmetrical pieces. So like over here is the reflection of over here. These are equidistant from here. It's the magic of the parabola. And you'll notice it hits the parabola at one special point. So let's do some vocab here. This point where the parabola sort of does the little loopy-loop, the turning point, if you will, the hinge, we call that the vertex. By we, I mean mathematicians smarter and older than me who started calling it this before I was born. I don't know why I said we like I was included. But we do call it the vertex. And we call this line, I just said before, I'll just label it in red, we call that the axis of symmetry. So we've got the axis of symmetry, and we've got the vertex. We've got it all here. Now what they're asking for is the equation for the axis of symmetry, so that's the red line, and the coordinates of the vertex. So the coordinates of the vertex here will be a little bit easier. So let's look. This is the origin, so we'll call that little point over there here. That's 0, 0. Looks like a little guy. Looks like a little guy's face. So if we zoom in, I'm trying to see. Let's see how many over we gotta go. Okay, so 1. So if this is 0, 1, 2, 3. Okay. So on the x-axis, which is this number line, that point lines up with 3. So our vertex is going to start with a positive 3. So 3, comma, something. Because when we write a vertex, we're going to write it as an x, comma, y. Okay. So let's see. Okay. So then this is, let's zoom in on this. This would be 0, -1, -2, -3, -4. So on the y-axis, which is this up-down vertical line, this point lines up with -4. So we would call this 3, -4. So 3, -4. And then, so let's see, which of these, right away I can eliminate 2 answers. It's not this one, and it's not this one. They tried to switcheroo. They put this is the y, this is the x. You can't do that. Trap. It's a trap. It's a trap. It's a trap. Now we got to decide between 2 possible equations. Is x equal to 3 or is y equal to 3? And remember, this is the equation for the axis of symmetry. So let's look at this line. Just looking at the line, you don't really need to know anything about equations. Remember, our 2 choices are x equals 3 and y equals 3. Because this is the vertex, so it's one of these, and it's either this or that. Because those are our only 2 options. The other 2 answers were wrong. So what does this red line look like? Does it look like x equals 3 here, or does it look like y equals -4? Well, if you see this red line, it crosses through this point that we wrote, 3. What is that? Is that 3 on the y or 3 on the x? It's 3 on the x. So this line is called x equals 3. If you're still not sure why, I totally get it. It breaks my brain too. I'll pick another random point on this line. Let's go here. That point is 1, 2, 3, comma, 1. Let's pick another point. This one. That point is 1, 2, 3, comma, 1, 2, 3, 4, 5, 6. 3, comma, 6. No matter what point I pick on this line, this number will always be 3 on that vertical line, and that number is the x coordinate, so we call it x equals 3. No matter where you are on that line, x is going to equal 3. So the correct answer is A. Is this the type of content you'd like to see more of? Please let me know if you would. That was a long time for one question, but I'd be happy to do the whole test like this if anyone is interested. Please let me know. Goodbye.